The pursuit of speed is often relegated to the adrenaline seekers, the risk takers, the record breakers. But our pursuit of speed is about something greater. It's speed in service of the experiences that make life precious. Imagine, if you will, flying across the Atlantic, doing business, and being home in time to tuck your children into bed, or where New Zealand becomes as accessible as New York. What would that do for families, for culture, for business? The technology for supersonic flight has existed for over 50 years.
This is the new supersonic airboat.
But it was too expensive for routine travel. At Boom, we are refining it, perfecting it, so that high-speed travel can be available to anyone. In the digital age, there really is no more distance. There is only time. Time from one another. Our mission is to remove that barrier, meaning more meetings in a day and more nights with loved ones. Where children grow up with their parents at home, and where relationships are no longer considered long distance. We see New York to London in 3 hours instead of 7. San Francisco to Tokyo in 5 hours instead of 11. We see world leaders spending more time in the same room, the acceptance of cultures, and the spreading of ideas. At Boom, we see the time saved as really the least important part. This isn't about time saved, it's about life gained. Together, we can make cities into neighborhoods and make the world a smaller place. Boom. The future is supersonic.
To accomplish our goal of affordable supersonic travel, we challenged our engineering team to create a design at least 30% more efficient than Concorde.
Concorde was designed 50 years ago, and its creators didn't have the technology for efficient supersonic flight. But today, we have better aerodynamics, materials, and engines. We've been working for the last 2.5 years on a revolutionary new supersonic design.
Concorde's designers worked in wind tunnels, where each iteration takes months and only a few designs can be tested. We work in virtual wind tunnels and have already run over 1,000 simulated wind tunnel tests, allowing us to produce a refined design, a breakthrough in supersonic efficiency. First is a concept called area ruling, a dynamically shaped fuselage that minimizes cross-sectional area with a gentle tapering in the aft cabin. This minimizes disturbances to the surrounding air, reducing drag.
The number 2 feature is called a chine. The chine is like a little wing that extends all the way up to the nose. And what the chine does on our airplane, on a commercial aircraft for the first time, is help create natural balance throughout a wide range of speeds.
Lastly, we refined the traditional delta wing design with high-efficiency airfoils and a swept trailing edge that reduces drag and helps quiet the sonic boom.
Today, we have the benefit of advanced materials. Carbon fiber composites allow us to realize the aerodynamic design with a strong, lightweight structure. To create a carbon fiber part, we first start with a high-precision mold, either CNC machined or 3D printed. We then apply layer after layer of carbon fabric and resin to the mold. Finally, each part is cured in an oven or autoclave under vacuum at temperatures of up to 450 degrees Fahrenheit. Cruising at 1,451 miles per hour, the nose and leading edges of the aircraft can reach temperatures of up to 307 degrees Fahrenheit. These carbon parts outperform aluminum at the high temperatures of supersonic flight.
Our aircraft needs a propulsion system that's powerful enough for Mach 2.2 flight, yet is also quiet and efficient. The propulsion system is composed of a variable geometry intake system and an efficient turbofan jet engine. The intake is like an adapter for supersonic flight. An intricate three-dimensional control surface creates shock waves that slow the air down to the ideal speed for the engine. Our engine is based on the same technology that powers modern subsonic aircraft, but with a customized fan and a variable geometry exhaust. Lastly, we use 3 engines for added reliability and safety. 2 engines are under the wing, and a third is in the tail, with a unique bifurcated inlet that is both efficient and beautiful.
For the last 2.5 years, we've been working quietly on the design. Finally, The engineering is complete and we have started the build process. In just over a year, our first airplane will be ready for flight.